kind of happy to be reporting that. What I'm going to do is give you a brief here's what I'm going to do. Review the problem that Multicast is trying to solve, which should take about 12 seconds. A brief history of what went on, where we're at, and then what's going on now, what's new, and I'll tell you a little bit about one case study that I happened to get some slides for, which is Spring, and I have a few conclusions, and if you want to look at these slides, they're there. So this is the Multicast thing, right? The idea was you're going to put one copy of the packet on any link, and it's a nice, I got these cool animations, you know. I don't know how to do this, but I think they look pretty good sometimes, as long as they're not completely gratuitous. But the point is that you wanted to put one copy of the packet on every link, and so you could optimize a lot of different things that way. So there were those two things about Multicast people were saying were the benefits of it. One is obviously that it's possible that you could get bandwidth savings on a Multicast. The other one was that there was a service model that allowed people to write new and interesting applications. So this was the Multicast story that we were working with over the last 5 to 7 years, I'd say. So what we really wanted to do was we wanted to be able to scale bandwidth without accumulating a lot of state, which was always a problem, because you had this cross product with the number of sources times the number of groups, and that was something that scared people off quite a bit, because these are all /32s essentially. And then there was always the issue of how do you assign the class D address space, because there isn't that much of it. So maybe to aggregate it, we haven't really seen how to do that, and maybe a way to do it dynamically so you could reuse it, since there isn't that much of it. So those were kind of the issues we were working around. Now, so here's a brief history of the Multicast universe, very brief. By the way, the flow of this is so that I can put some context here, so when we get to what's new, you'll know why it's new and not why it's old. But, okay, so we'll look at a little bit of history, where we are now, and some of the problems with these approaches. So, this is a quote from my favorite movie. So we have the M-bone. How many people had M-bone tunnels, DVMRP tunnels? And okay, so what that was about was you got a couple of, quite a few, really bright and productive people, and you get this stuff, right? You get Darknet, and you get DVMRP and NV and Whiteboard. And you know, to this day, I don't think there's something better than that out there for multimedia conferencing. It's a really impressive thing. So, and these things all evolved. But really what was underlying all this when I came along was the DVMRP M-bone. And this was this virtual tunnel thing. Many of you guys had connections. And, you know, it used RIP-like routing because of the first M-routes. I know, Bill, maybe you can correct me, but I think the first M-routes were really sort of derived from the BSD routes. And it was flood and frame technology, which means you just blast the packets everywhere, and when there's no receivers at the end of one of these things, that router sends back up, please don't blast the packets here. And so there was M-route, and this is very popular. But what was the problem with all this? Well, first off, you didn't have anything like, you know, you had a really pretty large tunnel infrastructure, and I think that the MIR guys drew this picture called Planet Multicast. I don't know if anybody remembered that. I tried to find that. But I used it in the first M-bone meeting because it showed that these tunnels were sort of everywhere. I think Meyer told me once that there were more than 100 tunnels crossing the fix, so that kind of reduced the multicast benefit. And then there was flood and print, which people didn't want because they were imagining that they'd have like HDTV flows or whatever, and you wouldn't want that kind of a flow crossing your network and then have to shut it back down. You wouldn't want to have that happen. And then DVMRP didn't scale to internet sizes, and there were policy issues. And then there were the address allocation problems. We never really solved that. We had a program called SDR, or SDR, SD, and SDR, and then we had this malloc working group, but we haven't really solved the address assignment problem for multicast, at least up to this point. So, and that was because the multicast address space is too small to be administered via a routing registry, or so we think. So all of that stuff is in the past, more or less. And today what we're doing is, for routing, most people like to run multi-protocol BGP, and there's several interoperable implementations of that out there. For tree building and forwarding, which in the multicast are routing and forwarding are done by two different protocols, we use, almost everybody's using PIM-Sparse, which used to be RFC 2362, but now it's completely confused and is being rewritten. So hopefully we'll get something a little bit more saying out of that. For source discovery, there's a protocol called MSDP that was built about 2 years ago, and I'll give you a little bit of an example of how that works. Address allocation. Peter and I had this idea that we could do the same thing as a Class A assignment experiment, subnetting, Class A subnetting experiment, if only the IANA would give us a /8 to mess with, and so they did. And that's RFC 2270. Basically, again, map the two your AS to the two octets and two middle octets, and you get a /24 statically assigned to you. Well, it turned out that a /24 isn't quite enough. And then management of multicast networks is a topic that always comes up. There's this one thing called MIM, but everybody's working on this. So this is the state of the world. Now, what's interesting about PIM-Sparse mode, which everybody's running now, is this last sub-bullet there, which is, watch what happens when, okay, so I have another animation. By the way, I don't know how to make these things or how to make them unanimate or anything, but, so this is the whole thing. So PIM has this notion of shared trees. So what happens is when you get a receiver, like down here at the bottom, do you want to use this thing? Okay, so when you get this receiver, I don't know how to operate it. Push on the top. Whoa, that's nice. Illuminate the target, I guess. So when you get a receiver down here, what happens is the receiver sends what's called an S-G join towards the source, or towards what's called the RP, because it really doesn't know the source at this time. That's the important thing. It doesn't know the source. It just wants to join a group. And what happens is the RP builds a shared tree down to it, and there's what's called a star-G state, which is sort of aggregating all the sources in the star. That was a benefit when the protocol was designed. And then if a source comes up, the way sources work is they do what's called registering. So this thing is an encapsulated multicast packet that's encapsulated in what's called a register packet, unicast to the RP. And then the RP explodes it on the shared tree like that. And then when the, this is the other thing. If you type ahead too much, you get animation, unexpected animation. Anyway, what happens is now a data packet came down, and the last hop router here can say, hey, I know where the source for this thing is because it saw the data packet. It's over here. And what can happen is, I think what I did was I went one too many. Okay, so here's where the data packet comes. This guy can see the source now, and now, this one right here was just that the RP would like to have a native path. You don't want to encapsulate packets all the time, so it's making a native path back to the source, and that's very nice. So now packets flow multicast and still encapsulated. That's all nice. And so this is the way the data flows right now. The RP will also tell the source to stop sending registers when it sees native packets. So that's nice too. Okay. So now what happens is the traffic flows this way down the shared tree, and now the last hop router can see where the source is. Right? This router right here towards the receiver. And this is the thing that you need to keep in mind. PIM-Sparse mode does this normal operation. So what it can do is, it can join back to the source tree, which is right here, because that's the shortest path back to the source, right? So what it does is send a join that way, and it creates S-G state along here, which was the state people were worried about, because that's kind of the cross product of 2/32s. And traffic can now flow in that way. And this is sort of superfluous, but this router can send a what's called a S-G RP bit prune to shut off the shared tree because you don't want data coming both ways if possible. So that's okay. So now this is gratuitous animation. But the bottom line is this guy sent an S-G join here and got data to flow this way once he saw the source. Right? Okay. So the question you might want to ask is that's kind of a lot of machinery, and if all you wanted to do was get that last step where you had a source tree from the source to the receiver, you might be able to do that in a little bit more efficient and easy way. If, for example, there's a well-known source like a broadcast television station or something. So the question really that came to mind is, well, what if the receiver could just tell the first hop router, its designated router, where the source for the group was, and it could just send it, the last thing it did, it could just send an S-G join for that. Well, it turns out that IGMPv3, which is the protocol that a host uses to signal, if you will, the first hop router can specify that. So that's a new protocol. So just hold on to that for a second. Okay, so that whole thing we just saw was actually in the intra-domain case. So that's what happens inside an enterprise. But what about in the inter-domain case? Well, we have this thing called MSDP, and MSDP is a real simple protocol. All it does is it sends around, if a domain gets a source, it just sends a packet that says, hey, I have this source and this group. So here's the example. This receiver up here just came up, and this thing right here is that whole PIM-Sparse mode interaction where it built a shared tree, okay, and that's what the thing has. It's sitting there. There's a receiver. Now someday a source comes up down here in some domain. Well, the source is going to send MSDP source active messages towards the domain where the receiver is, actually flood them in kind of this funny fashion and they will wind up going towards the receiver domain. Now, what this means is that the receiver can now just send an S-G join back to the source, just like PIM-Sparse mode does, right? Again, the thing to notice here for your own thinking about this is that, again, we're just trying to join directly to the source. None of this other machinery. All we're trying to do is join a source tree. So what happens is, well, then data starts flowing this way through the RP. But now the last hop router, which is not being shown on here, but just like last time, it sees the data and it can switch to the shortest path tree. So it'll send a S-G join, and that path might cut off the RP or may not if it flows through it. But the bottom line here is you went through this whole thing just to get on the leaf from a source tree, right? And so this could be, a broadcast source in somebody's in some content aggregator's network, and you wind up with a source tree. And again, the receiver didn't know where the source was, right? And that's what the RP and all this mechanism is for, so that we can find out where the sources are, receivers and sources can run it. So just keep those things in mind. I just want to give you a brief outline about what's going on in the real world today. A lot of this stuff is out there. I think PIM-Sparse mode has been out there. It's hard to nail this down because PIM-Sparse mode is something that's sort of morphed into what it is now, and it's kind of morphing into something else at the moment. But I think there have been implementations around for about 5 years, and if anybody knows differently, then let me know. And Multicast BGP or multi-protocol BGP for multicast and MSDP have been around and out in the field for like 2 years. The whole GLOP thing, everybody's using it, and unfortunately a /24 is in a lot of radio stations if you're like broadcast.com or something. There's about 200 ASs that are involved in doing MSDP. So you see ASs, you see SA messages for a little over 200. Same thing with MBGP, which makes sense. There may be about 8,000 networks in the MBGP table, and there's 12 or so public exchanges. And one of Kevin Almarov's students made a really nice web page that really summarizes all the stuff that's down here. It's pretty nice. There's a few other things. There's a lot of groups active at any time, but really, if you look at the number of groups that have been transmitted on in the last, say, time period, 24 hours or whatever, you'll see that like thousands of them have been transmitted on. So the addressing problem really is significant. There's a lot of multicast traffic around, and there's a lot of pretty powerful backbones around too. And if I have enough time at the end of this, I'll show you the Sprint one. It's kind of interesting because it works with both of the examples. So there's a lot of multicast out there, a lot of people doing multicast. There's been a lot of success with MSDP, MBGP, PIM-Sparse stuff, but there's still things that haven't been solved. So this is the review slide, and it has the real news on it. Basically, we do all this work just so that we might be able to construct source trees. And if we didn't, and if that's what we really knew up front that we wanted to do, there may be a simpler way to do that. This is quite a bit of machinery. So the question really is, what if we could just build these things directly? How would we do that? Well, that's what the news in multicast is right now, and that's where the whole multicast universe has some excitement going on, and it's going on around something called SSM, or source-specific multicast. It's called source-specific because we're assuming that the host will know where the last hop host that's wanting to join this group knows where the source is. Okay, so let's see what that is. All right, another nice gratuitous animation here. Basically, what you want to do is you want to just optimize for that case where the host already knows where the source is. Okay, so that's like you could get it out of who knows where you get it, but it's basically you want to build source trees, and you don't want to do all this other machinery. You just want to get these source trees established as quickly and as simply as possible. So the idea here is, well, can we simplify this, get the source tree immediately, eliminate dependencies on things like MSDP, and fix the address allocation problem? Can we do that? Oh, by the way, if you look on the IANA site for the allocated addresses. These were the V10 addresses that were reassigned to the source-specific multicast thing, and I'll show you why you need that. But basically, PIM-Sparse mode can already almost do this, right? We saw that it can join to the source tree. Last hop router, as soon as it sees the source, can switch to it. So nowadays, we've got something called PIM source-specific mode, which is sort of informal, but this is what this is about. Okay, and so this is the big news. And for those people, most of the applications around are one-to-many or few-to-many. And this style of multicast could really support one-to-many well and probably few-to-many well. So basically what you have is you have some out-of-band way of finding the source, and the canonical thing you'll think is it's a web server, right? You just click on the thing. And so you find the source. And then what you do is, well, surprise, you just send an S-G host report, and the first hop router just sends S-G join, and there's traffic. All that other stuff. And this can be inter-domain or intra-domain. All that other stuff, don't need that. Okay? But what you do need is, let me back up just a second. What you do need is, right here, is you need IGMP v3 to make this happen, right? Because the current versions of IGMP that ship in whatever host you have, Sun or whatever, is IGMP v3, which doesn't have the capability, v2, sorry, which doesn't have the capability of specifying the host. So, okay, so that's the thing. You can build a source tree really quickly using almost the machinery that's in PIM right now. So why can't you use it as it is? Well, first thing, this guy, when it gets this S-G report, for some range of addresses, it shouldn't send a *G join up this way to try to build a shared tree down here, because you don't want that. This guy, when the source comes up, shouldn't register. Right? Remember what registering was? You send an encapsulated packet to the RP, and it sends it down the shared tree. And if this guy doesn't register, the RP won't send MSDP SA messages either. So how can you know, how can any of these routers, this guy or this guy, last hop routers, how can they know? Well, you need a special piece of address space to do that. So they won't send, you'll have this source-specific behavior in 232/8, basically. Okay, so let's see what else I got here. So to state the obvious, this SSM thing really simplifies multicast deployment in the one-to-many case, and I would argue in the few-to-many case too. You don't have a source location problem because you got it out of band somehow. You don't have an address allocation, so you don't need MSDP. You have an address allocation problem because you're joining now to the source. So the effect of this is that all of the Class D addresses are local to the source because you're sending an S-G, so they start with like ports a little bit. So there's no address allocation problem, and it does give you a little bit of source control. You won't see this thing like John Lander was telling me when he was trying to run the NASA space shuttle. Some guy would consistently put up a picture of a Lego space shuttle on the same channel, and you could. I didn't ever see that. Did anybody ever see that? I don't know. John said it was there, and I never saw it. But you could do that because you have the shared tree, and anybody could get a packet down onto the shared tree. But now you're in the source tree that unless you can inject a packet onto that tree, spoof a packet onto that tree somewhere between the source and the receiver, there's no way to transmit on that one. So, and that's not going to be an easy thing to do. So, you won't. It's not like security or anything like that, but it does prevent these no-brainer things from happening. And as I said earlier, PIM-Sparse mode can almost do this already. And the way it's going to work is in the 232 space, the router closer to the receiver won't send *G joins towards the RP, right? Because we don't need a shared tree. The first hop router towards the sender won't register because we don't need to send that data down the shared tree. And since it didn't register, the RP won't send SA messages. But in any event, the RP shouldn't send SA messages. Oh, okay. So that's the big news in multicast right now, which is source specific. And everybody who's doing multicast is kind of excited about this. So let me look at the Sprint thing. So the Sprint guys have had this network up for a long time, a year and a half or two, and they've done a lot of things with it. But basically, it's this standard intra-domain thing where you have sparse mode, MSDP, and MBGP. So I'm trying to figure out how much time I have left. 1 minute. Oh no, that's 10 actually. Okay. So this is their network. Basically, they have 6 RPs spread out across across the country, they have full mesh MSDP between them, and they're using this trick that we wrote up called Anycast RP, where basically what you do is you define a new loopback with an Anycast address, which is just some address that you inject into your IGP, and so you advertise the RP or statically configure the RP from that address. And what that means is that you get convergence at the rate of your IGP, because since this thing is Anycast, wherever you are, you'll just go to the closest. Since the prefix is there, you'll just go to the closest one. So there's a internet draft on that if anybody's interested. I could tell you more about it. So then they have these connections at their various NAPs, and they also connected with Peter's network, ICM. I think that's Peter's network, and also with the old DBM RPM bound through AIMS. And and this was their picture of what their backbone architecture looks like. Basically, they had a bunch of customer access routers and a couple of backbone routers, and these things were all running PIM, and they had this OC48 backbone, and this thing ran really pretty well for the most part, or does run pretty well. Okay, and then they provided Multicast to Orlando, which worked pretty well, and that was a pretty nice example of how you could actually do this and make it work. There is some complexity in it because there are a lot of pieces, but we got it done. So, and it worked nicely. It worked really nicely. So, okay, so here's what they want to do. They want to augment their existing infrastructure because most people still believe there's a place for the shared tree MSDP style thing, but there's also quite a bit of excitement and a place for this stuff. So they want to do the sort of obvious thing, which is allow customers who want to have sources and receivers who want to receive that content to use SSM if possible. So this is what you really have to do. You have to get IGMP v3 to the hosts. You got to modify PIM on the edges the way I mentioned, right? Source specific PIM. Basically, don't send star comma G joins towards the RP, and don't register if the group's in 232/8. And then this is always an issue for providers because that's where the most of the customers might be for at least low bit rate services. So that's where they're at right now. I got this slide I got from Christoph a couple days ago. So this is what they're thinking. IETF, what's up with the IETF? Well, there's this whole massive number of documents surrounding this, but basically, let's see if this, oh yeah, okay, so basically this document was written by some guys at Sprint and some other people that sort of gave us a framework of how to do this. It included a lot of stuff about their own implementation, which we kind of ripped out. This is an architecture document about single source multicast and how it changes the service model, if at all. This is about the changes to PIM that we were mentioning. Don't send star comma G joins for 232, etc. This is all the IGMP v3 stuff. And then Greg has a BCP about what you do in 232/8, which is somewhat controversial right now because the BCP is suggesting, anybody who's a content provider or has customers might want to comment on this, but basically the BCP is saying that what you ought to do is filter and not allow groups that are in 232/8 into this MSDP environment. So that means that if you don't have IGMP v3 enabled hosts, then there could be content sources that your customers can't get. And that's a little bit controversial right now. All right, so a few conclusions. This is the one that just kind of, after I looked at my slides, I thought, man, I don't know how to use PowerPoint. So that was my major conclusion. But SSM, it is a really good and exciting thing that's going on for multicast. I think there's a lot of applications that are going to be able to take advantage of a much simpler way of delivering multicast streams. It doesn't replace MSDP, shared trees, all of that stuff for many applications yet. And the reason I question it is, I put that yet in there is because it seems to me that at least for few to many, if you're going to be able to survive the state for one to many, then you can do it for few to many. And then the whole thing is gated on the availability of IGMP v3 stacks for hosts, and that's the question that everybody has: is when will Microsoft have it? And I'm not sure, but that's probably the biggest gating factor right now because router vendors are getting IGMP v3 and PIM source specific PIM out to the field quickly. So, questions or comments?